welcome to a new episode. Here we are going to solve a new lead code problem, which is IPO. Generally, we have been given two arrays, that is profit array and a capital array, consisting of profits and capital. Now, we have also been given a K, which denotes the number of projects, the maximum number of projects that we can take up, and W is the initial capital. So the problem states that you have given some profits. Let's say the profit is 1, 2, 3. Yeah, profit is 1, 2, 3, and the capital for this corresponding profit is 0, 1, and 1. Now we have been given an initial capital for W, right? This is the initial capital. Now you can start up a project by this if the capital of this project is less than equals to this capital. So what to do? And you can take up only two projects. Likely k equals to 2. Now what to do? If the W is 0, that is the initial capital is 0. So can you name some projects whose range is 0? Yes, it is. The first project has an initial capital of 0. So we can do this, we can take up this work. So in the next project, can we take up this project? No, because the initial capital is 1. This is expensive right now. So my initial capital is 0. So we cannot take up this project. Can we take up this project? No, this is also not possible because W is 0, but the requirement is 1. So it is quite expensive for me right now. So what to do? Let's take up this first one. That is 1. And the profit is 1. And the capital is 0. Let's write this one. Yeah. So I have taken up this project 1 and 0 in the first iteration as a first project, and my profit current profit is 1 because the profit that is going to serve me after completing this project will be 1. So the current profit is 1. Now this is done, this project is done, there are left 2. Now my current capital is 1 because earlier the capital was 0, but I got a profit of 1, so my capital W will be increased to 1. Now which projects can I take up? Can I take up this project? Yes, I can. And can I take up this project? Yes, I can. I can take both of these projects. But the input says we can take up only two projects. I have already taken one project, k, that is k equals to 0. So I can take up just another project. And so what to do? We'll select this project, third project. That is because it is giving me the maximum profit. If I have taken this project, it will give me profit as a 2. But if I taken this last project, it will give me profit as 3. So what to do? I will take up the last one, that is 1 and 3. So currently my profit will be 1 plus 3, that is 4. So 4 is the answer. So this is how the problem wants me to solve this problem. Let's take up the second text case. This is P, let's say profit is, and the capital for them is 0, 1, and 2. Correct. Now my initial capital here is also 0. So, and the number of projects that I can take up is 3, right? So what to do? So can you name me any project that has a cost less than equals to this one? So first one has a cost of 0. So yeah, I can start this project. So let's say 1, 1, 0, 1, 0. Can I take up this project? No, it is a bit expensive for me right now. I cannot take this. Can I take up this project right now? No, I cannot because my cost is I have currently $0 in my hand, but this project wants me to do in two, so it is bit quite expensive. So I can only take up the first one. So currently the my profit will be 1 because this project will give me profit of 1. And the W will be also 1 because after completing this project, I now have $1 in my hand. So W will be increased to 1. Now I have exhausted one project, right? So let's Go to the second project. Now it is already done. The first one is already done, so I will ignore this. Now in the rest two of them, can I take up this project? Yes, I can because my initial capital is one. My current my because my current capital is one. I can take up this project. So now can I take up this project? No, I cannot take up this project. So I can take up only the second project. So what to do? Let's take up and finish this project. It will the profit will be 1 plus 2, that is 3, right? So by now I have completed two projects, but it wants me to do at least of three, maximum of three. Sorry, can I? Actually, it is not maximum three. It has to be, yeah, at most, yeah. Sorry, it is maximum of three, at most three. So can I if I go for the third one, that is the last one. Currently, my initial capital is 3 because in earlier cases I have completed two projects, so I have now $3 in my hand. So can I take up this project has been done? So I have only this one left. So can I take up this one? Yes, I can. So what to do? Let's take up this one. It will be 3 plus 3. It is so I have a profit of 6. So I have done completing all the projects because I have completed all the three projects. So I am done with this. My maximum profit is 3. So this is how the problem statement is. So what comes in your head when you see such type of problem? Of course, it is a greedy problem, right? It needs some greedy type of solution. So what can I do? I can sort the capital because I need to search that the projects which falls below this requirement, right? I have to search all the capital that falls below the W, that is the initial capital. So what to do? Let's sort this capital. Let's sort this capital and try to see which projects will come under this W, right? So what to do? Let's say in the first cases, let's say the first cases, the W was 0 and only this project had come under this W. So I have taken up only this one, 1 0 and added to this profit, completed and added to this profit. In the second case, W became 1. Here the W was 1, right? W was 1, correct. Here the W was 1. So which type of projects we can take? We can take both of these projects because it has a requirement of one and as well as one. We can take any of these projects, right? So, but we taken up the project that has a maximum of profit. So it is 3. I have taken up 3. This is how you are expected to do. So we can do one thing. We can sort the capital array by capital array by the ascending order of these values, and we just have an index. We keep on iterating through this capital array and try to find the projects that falls under the requirement. Now we add up all this. We will add up all the projects that can be done within a queue to because these projects will be calculated will summed up later on, right? Will be summed up later on because the maximum one, because here you can see I can take up both of these projects, right? So I need to have both of these projects in my queue and only the maximum of this will be added. So we can do you can come into our mind. Suppose if I need some kind of data structure that keeps track the maximum element being pushed into it, so we can. So what data structure comes into my mind? The data structure is heap, max heap, very specifically because the max heap always keeps tracks of the maximum element at the topmost corner, at the topmost position. So it's a very ambiguous. My statements are very ambiguous, but it will be cleared if I do coding. Let's understand by code. Let's find the length of this profit array. because the both of these will have a same length, so no need to capital the second one. Now to I need to make a pair of these both because it will be problematic if I do sort this only the capital. So I need to the orientation of this will be changed, and also I need to change the orientation of the profit because it will be quite difficult for me to keep track of the both profit and capital at the same time. So let's take a pair. Let's have a pair. Let's say let's have a pair. I do need capital and I do need profit, right? So my pair will have capital and profit. Capital is dot profit plus profit. Okay, cool. Sorry, type here. Yeah. Now I need to have an array list, temporary array list of type pair. Now I will keep on pushing. I will keep on having collection of a pair that has the profit and capitals as a key value as a pair element. So what to do? Let's do this thing. You will understand what I'm talking. Yeah, let's it is capital I. First is capital. Okay, cool. Second is profit. Cool. Yeah. Now you know I have talked about this thing. To I need to sort the capitals by the in the ascending order of the values because unless we do that we cannot track of this requirement, right? All the projects that will come under this uh, requirement will be added will be pushed into the queue for processing. So what to do? Let's sort this array. Let's sort this array by ascending order of capital. Yeah, cool. Let's ascending order of this capital. So my array has been sorted in the ascending order of this capital. Let's take a test case and just give a demo because it is quite ambiguous. Let's say I have this, right? I have this profit and capital. So I have made a data structure out of it that has a 0 and 1, that is the capital and profit pair, that is 1 and 2, that is 1 and 3. Yeah, it has been sorted in terms of the ascending order of the capital, so 0, 1, 2. So if a requirement comes like W equals to say 1, let's say this is, let's forget about this, let's say this is 2, let's say W equals to 1. So all the projects that is less than equals to W1 will be tracked. So this project will be picked and this project will be picked. These two projects will be picked because my requirement is one, and afterwards I will try to know which project will yield the maximum profit. This is how these things are done. Yeah, let's proceed with this thing. I have sorted it based on, yeah. Now what to do? I need a priority queue. I have told you one thing. I need a queue, and this queue must be of something that maintains the maximum element at this topmost element. That is which is an indication of a maxi in very simple words. So what to do? Queue. Let's convert into a maxi. Yeah, cool. This has been created into maxi. Okay, cool. Now, yeah. Now I need to have maximum of k times k projects. So just look through from k to 0. So now what we will do? Let's take an index. index, it will denote the project index of the project. Now I want to know that if temp dot get of index is less than equals to w. So if this condition is satisfied, because if the w is 1 and sorry dot capital, it will be capital if the w is 1 and all the capital of this project that is less than w will be pushed into the queue, pushed into the priority queue, because I want to know their profit, right? Yeah, all the profits will be because because since we need only the profit for this capital, we don't need a pair, so we can only push only the profit. That's why I have pushed only the profits. So it is in pair. Now let's index plus plus. Now I might get an add index about out of bounds exception because yeah, okay. So let's add a gut loss. Now after doing this, let's pop. Now this PQ will always have the maximum profit at the topmost element, right? So after doing this, I will only have the project that has a maximum profit, right? After pushing all for example, let's say let's say the projects that is 1 1 of capital, we will have a corresponding profit of 2 and 3. So both of them, if my W is 1, both of them satisfy this condition, right? So both of these projects will be pushed into the queue. But I need the project that has a maximum profit, right? So if I do poll, I need this maximum project profit. That means I need this project that is 3. That is 3, right? This 3. So I need this project. So what to do? Just pop it now. Since it's a maximum hit, I will get this 3 because among 2 and 3 I will get this 3 because it is at the top. So I got it. It is full. Now there can be one edge case because if the PQ isn't, because because if the W is kept at 7. So is there any project that has a in capital of 7 or sorry, is there any project that has a no, sorry, the let's say suppose for example, let's say for no, let's say for example their capitals like uh 4 2 whatever 2 or 3. Yeah, this is the initial capital of some projects and at my W is 1. Can we start any project? Because my initial capital is 1, but all the projects have initial cost of 2 to 3. So can we start any project? No, right? So this PQ, this condition will never be executed. So my PQ will be empty. Now under such circumstances, if I do PQ dot poll, I will get some exception, right? So what to do? Let's add a gut loss. Yeah, this is the gut condition. If my PQ is empty, just break it now because I have found nothing. If this condition satisfies, that does mean that there is no projects available that I can start with. So I don't have nothing to do from this one. So this is the end of it. So this is how this thing will work. Let's run this one. I did something mischievous. Yeah, it's a typo in my code. Yeah, the test is passed. Yeah, well, also passed. So what is the time complexity of this code? The time complexity can be, let's say we have done a sorting on this the array, so it will be order of n log n. Let's say let's discuss the time complexity. We have done the sorting, so it will be order of n log n for this sorting. Now you can notice here we do a offer operation. If the projects we can, if there are some projects that we can take, there are some offer operation. For this operation, we will have login operation, because the if we do something, if we're adding something into the priority queue, there it will be of login operation, and there are also poll operations, so it will be also login operation. So it will be see, it will be approximately order of login, because in login, because it is the greater quantity, it is of greater quantity, so it will vary. It will, the time complexity will depend on the in login, the bigger terms. But to be very broad, let's say this is the term complexity, and for the space complexity, we do need a priority queue that whose size will be based on this conditions, because how many, the maximum number of projects that can be into the PQ. Let's say K is the maximum number of projects, max number of projects that has whose capital is less than W, which satisfy that, in simpler, which satisfies this condition. Maximum number of projects that satisfies this condition, that is capital less than W. And I also taken a temporary array of size n, so it will be n also, k plus n. So this is it from me. It was a very good problem, actually very good problem. It's a hard one, but it's a good one. So yeah, it was a really problem and a nice problem. That's it from me. Thank you.